Hello everyone. Today I'm going to talk about my structural analysis project. My project for structural analysis it's a profile structure. I will show you my structure and all the calculations I did for this project. My chosen structure is according to the design. It's a beam-like structure, a simple supported beam, and that structure is located in Swaniston Street, Melbourne. The second task was calculating the moment of inertia AY, BY for the shear force and bending moment, and then calculating the slope and deflection. First of all, my beam structure is a rectangular beam with the span of 9 meters, width of 300 millimeters, and depth of 400 millimeters. The material of the beam is steel, therefore E is 200,000 MPa. First of all, I've calculated the moment of inertia, which is I use the equation of PD square over 12. Why we calculating the moment of inertia? We need the moment of inertia to find out later the slope and the deflection. After calculating the moment of inertia, I went to calculate AY. I used MPZ equals to 0. To find out AY, I had to go clockwise with AY minus, and then I found out AY is 4.99. I rounded up to 5. After finding out AY, it's easy to find BY. AY as 5 kilonewton and BY as 10 kilonewton. With using similar triangle, I want to find out the first equation for the shear force. I went anti-clockwise with 5 kilonewton as positive and V as negative because it goes clockwise. And then first thing I found out the first equation with V equals 5 minus 3.33 over 18 x squared. And then when x equals 0, V will equals 5 kilonewton. And when x equals 9, V will equals minus 10 kilonewton. And when V equals 0, x will equals 5.2 meters. After finding out the first equation, I want to find out the M, which is the second equation we need for the bending moment diagram. I used to find out the M, I used the equation for the shear force with x equals 0, M will equal 0. But when x equals 9, M will still equal 0. But when x equals 5.2 meter, M max will equal 17.3 kilonewton meters. And then I draw the shear force diagram with the bending moment diagram after I calculate the first equation and the second equations. And here is the diagrams. After calculating the shear force and the bending moment, I went to calculate the slope and deflection. And this part was a bit hard because it has a lot of calculations. But with the help of the teacher and the consultation time, I managed to do it at the end. I used the curvature equations to find out the slope and deflect. To find out the slope, I had to integrate the curvature equation. And for the deflection, I had to double integrate the equations. And then I got those numbers. And then I had to calculate the slope and deflection 3 times. When x equals 0, and when x equals 9, and when x equals 4.5, which is in the middle of the span. And I got those answers. And this was task 2. And then for task 3, I had to calculate the principal stresses in plane, shear stresses, and failure planes and the profile structure. And first of all, from the bending moment diagram, we know M equals to 17.3 kilonewton meters. And the cross section of the moment of inertia of the beam, this one, with the width of 300 millimeter and the depth of 400 millimeters. First of all, I calculated the I with this equation. And the second thing, I calculated I got the Y as the half of this cross section is 200. And because I have M equal to 17.3 and I equals to 1600 times 10 to the power 6, and I got Y from 1 and 2 and 3, the maximum bending stress, which is a theta x, will equal 2.16 MPa. After calculating the theta x, the maximum bending stress, I had to calculate the maximum shear stress. And for the maximum shear stress, I know V is 5, which is the maximum shear force, and the tau and I had to use this equation. And then I got 0.031 MPa. So at the end, I got the maximum shear stress less than the maximum bending stress, which is okay. After that, I've calculated the maximum stresses principle. Failure plane due to the normal stresses calculation, theta 1 and theta 2, at the middle of the span, and the maximum normal stress will occur there. So the maximum normal stress will occur at the middle of the span. I used this formula to calculate the maximum normal stress, and then I used the quadratic formula, and I got 0 and 2.16. After that, I calculated the in-plane shear stresses, the tau max. With the same process, I got tau max equals to 0.31. A max normal stress of 2.16 is located at x equals 0. And if theta x and theta y equals to 0, theta 1 and 2 will equals to 0.031, which is the same as the maximum shear stress. After that, I calculated the plane angle. And to calculate the plane angle, I had to use the tangent method. With this method, I found out that theta p and theta s. Theta p will be plus or minus 45 degrees, and theta s will equal plus and minus 45. As seen above in this calculation, I provided key result from the calculation process. There is no hard part for me for this model, but I've spent a lot of time on maximum deflection and slope, because this part most complicated calculation. And I did the calculation several times for bending and shear stress as well. And eventually I got the final answer. For the principal stresses and the stresses of plane shear, I did not really know what they really are at the start. So I watched the recording lecture many times, and finally I got the answer. This assignment helped me to develop my ability to calculate and solve problems. And now I'm looking forward to the final exam with more confidence and more knowledge of the course, as I feel that this task covered most of the subject topics.